Near the very top of the highest mountain on Earth, the rock turns pale. For most of the long climb, the stone is dark and folded, the grey of old mud pressed hard for an age beyond counting. But the final pyramid of the mountain, the last few hundred meters, the part that stands against the sky in every photograph ever taken of the place, is a different rock entirely. It is limestone, soft, chalky, pale grey, the kind of stone you'd expect to find in a low quarry in gentle green country, not the better part of 9 kilometers up, in a wind that can freeze bare skin in under a minute. And it is not blank. Brush away the snow, hold the rock close, and you'll see it is crowded with small pale shapes, faint rings, broken stems, the scattered pieces of animals that once lived on the floor of a warm, shallow sea. Those animals are real, and they are older than almost anything you can easily picture. The summit of the mountain we call the roof of the world is built, in part, from the floor of an ocean, old seabed, carried whole into the sky, the bottom of the world made into the top of it. How that happened, how a seafloor full of shells comes to rest nearly 9 kilometers above the waves that made it, is the story we're going to spend tonight inside. Think of that pale stone as a door then. We're about to step through it, back into a world that no longer exists, and walk the whole long way home. It's a slow story and it isn't finished, which is part of why it rewards being told slowly. But the shape of it is simple enough to hold in one hand. A long time ago, the land that is now India was nowhere near where it is now. It lay far to the south, joined to Antarctica and Africa and Australia in one great southern continent, in a warm world we would struggle to recognize. And then it broke away. It set off northward, alone, across an open ocean, the way an iceberg leaves a shelf, slowly, without any intention, and without any way of stopping. The crossing took tens of millions of years, and waiting on the far side of that ocean was Asia. When the two of them finally met, there was no sea left between them to give way. The ocean floor that had lain in the gap, the mud, the limestone, the bodies of all the small creatures that had been settling there quietly for ages, had nowhere left to go. It was caught between two continents that would not stop pressing together, and so it was crumpled and driven upward, layer over buckled layer, until pieces of that drowned sea bottom stood higher than any land ever had. The Himalayas are that sea floor, raised. The pale summit stone, with its rings of sea creatures, is the receipt, left in plain sight at the very top, where the air finally runs out. Stand at the foot of them today, and the scale is hard for the mind to take in honestly. The range runs more than 2,000 kilometers, a wall of rock and ice with 100 summits higher than anything in Europe or the Americas. On a clear morning from far off, the highest peaks seem to float, too pale and too high to be fixed to the ground, more like a bank of cloud that forgot to move. And every one of them is held up for now by the slow shove of a continent that will not stop pushing north. All of this is recent, as the Earth keeps time. The mountains you can see today, the tallest on the planet, are young, younger than the oldest sharks, younger than the first flowers. And the collision that lifted them has not ended. India is still moving north. It pushes up under Asia at about the speed your fingernails grow, a few centimeters a year, far too slow to feel and far too steady to stop. And it hasn't paused once in 50 million years. The mountains are still climbing. By the time this long night is over, the summit of Everest will stand a little higher than it does right now, by less than the width of a hair, but truly, the way it has risen, hour after hour, since long before there was anyone here to notice. The crash we're here to talk about is not something that happened once and ended. It's something that is happening, tonight. Beneath a great many sleeping people, beneath the mountains, beneath the old seabed at the top. There's something steadying in a fact like that if you let it settle. We live inside hours and days, inside the small weather of a single life, and it can start to feel as though that weather is all that time is. Then you learn that the stone at the top of the world is the wreckage of a drowned sea, lifted there by a collision older than our whole species, and the grip of the day loosens a little. The earth keeps a longer, gentler kind of time than we do, a patient and forgetful kind, and we're allowed, for a little while, to lie down inside it. There's a comfort in being this small against something so slow and so old, the comfort of being briefly held by something that will outlast you and asks nothing of you at all. And before we set out across that ocean together, one small thing. If you find yourself drawn to this kind of slow descent into deep time, to nights spent walking quietly through worlds the earth has already finished with, consider subscribing, and we'll keep making these journeys together. And if you'd like, leave a note in the comments telling us where you're listening from tonight, your city, and the hour it is where you are. It's always something, seeing how far this quiet journey travels in the dark, and how many of us are awake together inside the same long night. Now, let's go back to the beginning. Not to the mountains, which come very late in this story, but to the world before them. A single joined land low in the southern half of the planet, warm and unhurried, with no hint anywhere of the journey about to begin. Let's start there, with a continent that is still whole and still home. Picture yourself standing on a low rise of warm ground in the long middle of an afternoon, something like 200 million years ago. The air is thick and green and smells of resin. Behind you, a forest runs back toward the interior. Tall, cone-bearing trees, tree ferns standing as high as houses, squat cycads pushing up between them like pineapples carved from stone. There are no flowers anywhere. The world has not invented them yet. A wide brown river slides past without any hurry, and out in its shallows something large is feeding, slow and unbothered. There is no city on the earth, no field, no path, no smoke on any horizon, and no one, anywhere, to stand where you are standing. Stand there anyway for a moment and look south. If you could lift straight up off that rise, the way you sometimes rise in a dream, weightless, the river narrowing to a thread and the forest blurring to a green stain, you would see that the land does not end. It runs south and keeps on running. Past the rise, it joins the body of a single enormous continent, one that draws almost all the land in the southern half of the world into one piece. The ground that will one day be Africa is part of it. So are South America and Madagascar and Antarctica and Australia, and a broad blade of rock pointed north that will one day be called India, the very ground that is going to stand in the far future at the top of the world. For now, it is just one more stretch of a seamless whole, one coastline wrapped around one interior, one ocean lying along the northern edge of everything. It is hard, from our broken-up world of separate continents and narrow seas, to feel how complete that arrangement was. You could have walked clear across it, from one ocean shore to the other, without once crossing salt water. The same families of plants grew along its whole length. The same kinds of animals wandered from one side of it to the other. It had the deep, settled permanence of something that has been in place for an immense span of time and gives every sign of staying, which is just what anything living on it would have taken for granted, if anything living on it had been in the habit of taking things for granted at all. This continent has a name now, though no one who ever walked it could have given it one. We call it Gondwana, a word the Austrian geologist Eduard Suess borrowed back in the 1880s from a district of central India and stretched to cover the entire lost world. He named the ocean along its northern shore as well, the Tethys. From his study in Vienna, Suess could tell that this southern land had once been whole and real, The evidence was scattered all through the rocks, and it was very hard to argue with. Across continents now held apart by thousands of kilometers of open water, the same fingerprints kept turning up. One tough, tongue-shaped leaf, a plant we call Glossopteris, lies pressed into stone in India, in southern Africa, in Australia, in South America, and under the ice of Antarctica. It is as if a single forest had been pulled apart and its pieces flung to the far corners of the planet. The long parallel grooves that glaciers gouge into bedrock run across all those lands too, and they point in directions that only make sense if the lands had once been jammed up hard against one another. Lay the coast of Africa against the coast of South America, and they close like two halves of a torn page, the writing running clean across the rip. Everywhere, the rocks insisted on the same unreasonable thing, that these places, oceans apart, had once been a single body of ground. But what had become of it? On that question, Suez and nearly everyone of his generation reasoned in precisely the wrong direction. Continents, they were sure, did not travel. The great masses of the earth held their places. So they pictured the missing land, the bridges of rock the fossils seemed to require, sinking instead, foundering quietly beneath the waves, leaving the modern continents stranded where they sit, like furniture left behind when the floor between two rooms gives way. It was a careful answer, and an understandable one. It also turned out to be entirely wrong. What actually happened was stranger and slower than any sinking. The continent had not held still while the sea climbed up around it. The continent itself had come apart, not in a single event, but across tens of millions of years, seam by seam, the way something vast and long settled finally yields to a pressure too patient to watch. Far below the surface, the slow churn of the planet's hot interior worked the great landmass into pieces. New cracks opened and filled with seawater. South America eased back from Africa, and the rift between them flooded and widened into the infant Atlantic. Antarctica and Australia drew off toward the south, and the long blade of rock pointed north. The ground that would become India was about to do something none of its neighbours would quite manage. The world we live on is largely the rubble of that breakup. Open an atlas to the southern half of the globe, and you are looking at the scattered fragments of Gondwana, still drifting, still easing apart by a few centimetres a year. There is South America and Africa with their famous facing coastlines. There is Madagascar, set just off the African shore like a chip knocked loose from the edge of it, and Antarctica, alone now beneath its ice, and Australia, far out on its own in the southern sea. Every one of them is a shard of the single continent you were standing on a few minutes ago, a survivor of the same slow shattering, and India is the strangest survivor of all. Where the others simply drifted apart and came to rest, India alone went looking for a new continent to run into. For a long while, it travelled in company. India and the great island of Madagascar moved off together, a single raft of rock easing north into the southern Tethys side by side. But around 88 million years ago, the two of them came apart. A deep crack opened between them, the sea poured into the gap, and India pulled away to the north on its own. Tens of millions of years after that, near the very end of the age of the dinosaurs, it let go of one last piece, a cluster of high ground that would settle into the water as the Seychelles, the granite islands that sit, to this day, oddly alone in the middle of the Indian Ocean. A few stones still resting on the dock after the ship had finally pulled away. And so India was alone. A whole continent, land enough to be a world in itself, set loose in open ocean with no other shore in sight. For tens of millions of years it would stay that way. An island the size of a country, sealed off by deep water, left to become entirely its own. Whatever lived on it answered to nothing but the island, its own forests and rivers, its own weather, its own slow experiments in what a living thing might become, with no traffic in and none out. To anyone watching, it would have looked like any island looks, a place complete in itself, going about the patient business of being a country, with no notion that it was a country in motion. It looked permanent. It looked as though it had always been there and always would be, and the whole way, mile by patient mile, it was carrying north the old seabed and the pale stone that would one day be lifted into the thin, cold air at the very top of the world, without the faintest idea that it was going anywhere at all. All of this we now know in fine detail. We can name the dates, trace the cracks, and read the drift in the rocks almost the way you would read the entries in a ship's logbook. But for nearly all of human history, and for the first decades of the very science that should have known better, the thing this chapter has been describing, a continent crossing an ocean, was held to be flatly impossible. Not merely unproven, impossible. And the first person to study the fit of the coastlines and say, out loud and in plain words, that the continents themselves must have moved, was met not with curiosity, but with something close to scorn. Before we follow India out into the open Tethys, it's worth stopping a while with that man, with someone who turned out to be right far too early, and who paid for it with the rest of his life. The man who first looked at the broken pieces of Gondwana and understood correctly what had happened to them was not a geologist. He had never trained as one, never held a post in one, never earned the right, in the eyes of the people who did, to an opinion on the matter at all. He was a weather scientist, a student of the upper air, a balloonist, a man who had twice crossed the ice of Greenland on foot. His name was Alfred Wegener, and the fact that he was an outsider wandering into a field that was not his own runs all the way through what happened next. It is part of why he saw what the experts had missed. It is also part of why, for the rest of his life, and for 30 years after his death, almost no one would believe him. He came at it sideways, the way outsiders often do. Trained first as an astronomer, then drawn into the young science of weather, Wegener spent his working life in the cold corners of the world. But sometime around 1910, studying a map of the Atlantic, he was caught by the same thing that had caught others before him. The way the eastern shoulder of South America seemed made to nest into the hollow of Western Africa, as though the two coastlines had once been a single line since pulled apart. Others had noticed it and shrugged it off as a coincidence. Wegener could not. And where Suez and his generation had explained the matching lands by imagining the country between them drowned, Wegener took the harder, stranger path, and, as it turned out, the right one. The continents had not held still while the land between them sank. The continents themselves had moved. They had once been packed together into a single mass. He would later call it Pangaea, all the earth. And they had since broken apart and gone wandering, and were wandering still. He built his case the way a careful detective builds one, from many directions at once. The fit of the coastlines was only the opening of it. Mountain ranges, he showed, lined up across the ocean, the same belts of folded rock running off the western edge of Africa and resuming beat for beat in Brazil, as though a single range had been sawn through and the halves hauled apart. Fossils of the same creatures turned up on shores now a whole ocean from each other, among them a small freshwater reptile called Mesosaurus, an animal of still lakes and slow rivers, found in the rocks of Brazil and again in the rocks of southern Africa, and nowhere in the sea between. It could not have swum the Atlantic. It could not survive in salt water at all. Either it had walked across land that no longer exists, or those two coasts had once been one. And the part that is easy to hurry past is the age of it. That little reptile had been dead for more than 250 million years. The joined world it recorded was already old beyond all imagining. Wegener was not reading recent history off the rocks. He was reading the deep past and finding written into it the clear outline of a single shattered continent. Not everyone dismissed him. A few working geologists found the evidence too strong to wave away, and one of them did something rare. He went out and put the theory to a hard test. Alexander du Toit, a South African field geologist who could read rock as well as anyone alive, reasoned that if Africa and South America had truly once been joined, then the particular formations he had mapped along the African coast ought to continue in the very same order on the far side of the ocean. In 1923, he crossed the Atlantic to find out, and there they were, bed for bed, fold for fold, the African geology taking up again in South America almost exactly where Wegener's reconstruction said it should. It was the kind of fulfilled prediction that is supposed to be the whole point of science. Du Toit was persuaded for the rest of his life and would one day dedicate a book to a man he had never met. And still it was not enough, because of a hole in the center of the argument that Wegener could never close. He could show from a dozen directions that the continents had once fit together. What he could not explain was the moving. What force on Earth could be strong enough to drive a continent across the floor of an ocean? His best guess was that the continents ploughed through the oceanic rock beneath them, like ships shouldering through pack ice, pushed along by the faint outward tug of the planet's spin and the slow pull of the tides. On this, his critics were simply right. The British geophysicist Harold Jeffreys ran the numbers and showed that those forces fell short by a factor of thousands, that a continent trying to bulldoze through solid ocean floor would buckle and shatter long before it travelled anywhere. Wegener had the great fact right and the mechanism hopelessly wrong. His sense of speed was off as well. He pictured the continents tearing apart at tens of meters a year, when the true rate, as we would learn only much later, is closer to a couple of centimeters, about the width of 2 fingers held together. Across the whole of Wegener's life, the Atlantic widened by perhaps a single meter. The motion was so slight, so patient, that nothing in his day could catch it in the act, which left him forever pointing at a vanished past with no way to show a single thing stirring in the present. None of this, though, accounts for the sheer heat of the reaction, which ran well past honest doubt into something closer to contempt. The hostility burned hottest among American geologists, many of whom had built their careers on the assumption that continents stay where they are. One of them dismissed the whole idea as a thing that would make geology forget everything we have learned in the last 70 years and start all over again. The head of a respected scientific society is said to have called it, with feeling, utter damned rot. That a German weatherman had wandered in from outside the field only made it easier to wave him off as a dreamer. And it is worth being fair to them, because from this distance it is easy to feel superior. Set yourself down in that room, knowing only what they knew, a sweeping claim, no workable mechanism, no motion anyone could measure, and the few numbers on offer plainly far too large. And you would very likely have doubted him too. The skeptics were not fools. You could accept that the continents had once been joined and still refuse to believe they had sailed apart, and a great many careful people did exactly that. What was missing was proof of the motion itself, and in Wegener's lifetime, no such proof existed. His own end came on the ice he had given his life to studying. In the autumn of 1930, he was leading an expedition across the Greenland ice cap, and a small team at a weather station far in the interior was running short of food before the winter closed in. Wegener set out by dog sled to bring them supplies. He reached them, but there was not enough to go around, and so, rather than become one more mouth at a starving table, he turned almost at once to make the long trip back to the coast. He left the station on the 1st of November, his 50th birthday, with a single young Greenlandic companion named Rasmus Wilhelmsen. Somewhere out on the white interior, in the cold and the exhaustion, his heart most likely gave out. Willemsen buried him with great care, sewn into his sleeping bags, and marked the spot the only way the empty ice allowed, by standing a pair of skis upright in the snow. Then he walked on toward the coast, alone, and was never seen again. The following May, a search party crossed that blank plain and saw from far off 2 skis standing against the sky. They dug down and found him there, exactly as he had been left. They did not move him. They marked the grave and let the ice keep him, and the ice has kept him ever since, carrying him slowly down and outward, the way it carries everything, the way it would one day carry a continent. He died believing he was right, and he was right, and hardly anyone alive yet knew it. The hard part is that the proof he needed was never lost or undiscovered. It was simply unread. All the while the argument raged. Every lava flow and every bed of rock on Earth had been quietly keeping the record itself, each one noting down, at the moment it formed, the direction of the planet's magnetic field, and with it a faint trace of where on the globe that piece of the world had been standing. The continents had been writing the whole story down the entire time, in a script no one had yet learned to read. It would take a new kind of instrument and a young scientist willing to trust a very strange result before anyone could open that record at last and see, set plainly into the stone, that India and all the rest had truly crossed the surface of the Earth. Behind a laboratory in Cambridge in the early 1950s, there stands a small wooden hut with almost no metal in it. The nails are brass and the fittings are wood, because iron of any kind would spoil what happens inside. Coils of wire wound around the walls cancel out the Earth's own magnetism, so that the air within the hut is, in a way, nowhere at all. A small pocket of the planet with its compass switched off. At the heart of the room sits a strange and delicate instrument, a sliver of magnet hung from a thread so fine it would snap at a breath, with a tiny mirror fixed to it that throws a thin spot of light onto a scale across the room. The magnet is balanced so finely that the faint magnetism of a single chip of rock laid on the bench beside it is enough to make it turn. And a young man is leaning in to watch that spot of light, keeping very still, because the rock he has just set down is a piece of India, and the light is beginning to tell him where India used to be. To understand what the light was saying, you have to know what a rock can remember. When molten rock cools, when a lava flow stiffens and hardens into stone, the countless tiny grains of iron-bearing minerals scattered through it behave, for a moment, like a swarm of miniature compass needles. Each one swings to line up with the Earth's magnetic field as it stands at that place on that day, and then, as the rock locks solid, they freeze in position and hold it. They go on holding it for as long as the rock survives, through tens of millions of years, through burial and uplift and the slow turning of the world. A fossil compass, set the instant the stone was born and faithful to that instant ever after. And the compass records more than a direction. The Earth's magnetic field does not lie flat along the ground. It dips down into the planet at an angle that shifts with latitude, plunging steeply near the poles, lying nearly level at the equator and taking every angle in between. So the frozen tilt locked inside a lava flow is a record of how far north or south that lava lay when it cooled. Read the dip, and the rock will tell you its old latitude. It will tell you, in plain terms, where on the face of the Earth it once stood. This was precisely the thing Wegener had never had. Not another argument that the continents had once fit together, but a way to fix where a given piece of the world had been at a given moment, and so to prove that it had moved. The instrument that could read so faint a signal had arrived almost by accident, out of a wrong idea chased by a brilliant man. Patrick Blackett was a physicist of the very first rank. He had already won a Nobel Prize for his work on cosmic rays, and in the late 1940s he became gripped by a bold and sweeping notion that any massive spinning body, the sun, a distant star, the Earth itself, might generate a magnetic field simply by turning. To test it, he needed to measure magnetism more delicately than anyone ever had, and so he built a magnetometer of extraordinary sensitivity. The theory was wrong. His own careful experiment killed it. But the instrument he had built to chase a phantom turned out to be the perfect tool for an entirely different task, listening to the whisper of magnetism held inside ordinary rock. The wrong question had built exactly the right key. The young man in the hut was Edward Irving, Ted to everyone who knew him, and while still a student in 1951, he had seen what the new instrument might be made to prove. If continents really moved, then no continent had a wilder story to tell than India, which the rocks and the fossils placed far to the south, down among the other broken pieces of Gondwana, before it somehow ended up driven hard against the underside of Asia. If India had truly made that crossing, then the lavas it carried, cooled while the continent still lay deep in the southern world, ought to hold a frozen compass pointing at a southern sky. So Irving got hold of some. Through a chain of contacts that reached all the way to the head of the Geological Survey of India, chips of dark Indian basalt made their way to that hut in Cambridge. One by one, he set them beside the trembling magnet and read off the angle locked inside. And the rocks answered exactly as a travelling India should. They had cooled far down in the southern hemisphere, by the tilt of their magnetism, something close to 55 degrees of latitude from where India lies today. A journey of nearly 6,000 kilometers straight up the curve of the world, set down in stone. It was, by any fair reckoning, one of the first solid measurements of continental drift, the very thing the world had refused to grant Wegener. And here the story turns almost comic, the way real history often does. Irving folded the result into his doctoral thesis at Cambridge, and the university failed it. For reasons never fully recorded, though more than one person suspected the findings were simply too radical to be swallowed, the examiners declined the degree and handed him a lesser one instead. The young man who had just measured a continent crossing an ocean did not, for the moment, qualify as a doctor of philosophy. By his own cheerful account, he went out with some friends, got thoroughly drunk, and got on with it. He was right, and he knew he was right, and this time the rock was on his side. Within a few years, other laboratories working on Indian stone of their own were finding exactly the same thing, and Cambridge came round in the end and awarded him its highest doctorate after all. Irving, unlike Wegener, lived to be believed. And once the journey could be measured, a second surprise climbed out of the numbers, not only that India had crossed an ocean, but how fast it had done it. As more rocks were read, and as a second great archive of the Earth's magnetism came to light, in the striped record laid down across the floors of the spreading oceans, scientists could reconstruct not just where India had been, but how quickly it had travelled from one position to the next. And for a long stretch of its voyage, India had moved at something like 15 to 20 centimetres a year. That is roughly the rate your hair grows. For a continent, it is astonishing. It is faster than any other landmass is known to have travelled before or since, fast enough that by the slow standards of the Earth's crust, India was not so much drifting as sprinting. Today it has eased to a crawl, pressing into Asia at about the pace of a growing fingernail. But in its prime, it ran several times quicker than that, and it held the pace not for a year or a century, but for tens of millions of years on end. Over a single long human life, moving like that, the whole subcontinent would slide past you by more than 10 meters, and it never once paused to rest. Why India alone should have moved so fast is a question still argued over, but the leading answer is strangely fitting. India may have been pulled north by not one engine, but two. The floor of an ocean, once it grows old and cold and heavy, tends to sink back down into the hot interior of the planet, peeling away along great undersea trenches and dragging the rest of its plate behind it, the way a chain sliding off the edge of a table hauls the rest after it. Most continents are towed along by a single such sinking slab. India, it seems, had two long trenches devouring the floor of the Tethys ahead of it, two heavy slabs sinking into the depths and pulling the continent after them. Twice the engine and nearly twice the speed. Whether that is the whole of the answer, no one can yet say with confidence, but it would account for a continent that behaved less like a drifting raft than like something being reeled steadily in. And here is the quiet wonder at the heart of all of it. No eye ever saw that crossing. There was no one to watch India pull away from Madagascar, no one to mark off the thousands of kilometers of open water, no creature that lived through the whole long voyage and came out the far side to remember it. Every witness is long gone. The only thing that kept the record was the rock, the patient iron locked in the stone, holding the tilt of a vanished sky for 100 million years, until a young man in a wooden hut thought to set it beside a magnet and ask it where it had been. A journey that nothing alive had survived to tell had been quietly telling itself the entire time, written into the ground, waiting only for someone to learn the alphabet. That particular rock Irving questioned, the dark Indian basalt, held one more secret in it, beyond the journey it had recorded. It had been born in fire. The lavas of India did not seep out gently. They erupted in one of the most violent fits of volcanism the planet has ever staged, at almost exactly the moment on the far side of the world that the long age of the dinosaurs was brought to its end. To understand that stone and the strange and violent passage of the continent that carried it north, we have to go back to that morning, the morning the ground itself caught fire. Start with a number, because the number is the only honest way in. Somewhere around 66 million years ago, in a stretch of time that is, by the planet's reckoning, almost no time at all, roughly 1 million cubic kilometers of molten rock came up out of the deep earth and spread itself across the western half of India. 1 million cubic kilometers is a figure the mind simply slides off, so lay it against something you can stand on. Take a country the size of France, every last hill and valley and town, and bury the whole of it under 2 solid kilometers of black volcanic stone. That is the scale of what happened. We call the result the Deccan, a flood of lava so enormous that what survives of it today, after 66 million years of wind and rain have carried much of it away, still forms a plateau the size of a large nation, layer of cooled rock stacked on layer in a pile that stands, in places, 2 kilometers thick. Stand at the edge of one of those eruptions while it is happening, and the word that comes apart in your hands is volcano. There is no cone, no crater, no single mountain doing the work. What you are looking at is the solid ground coming open along a glowing seam that runs off in both directions past the curve of the horizon, a crack in the earth wider than a city, a river of fire feeding a sheet of molten rock that crawls out across the land faster than you would care to walk away from it. The heat reaches you from kilometers off. Above the whole length of it hangs a pall of volcanic gas, sulfur and carbon dioxide breathed out of the planet's interior in amounts that will, over the long life of the eruption, reach right around the world and lean on its climate. There is nothing here of the tidy volcano we carry around in our heads. This is the inside of the earth, simply coming out. And while India was drowning its western flank in fire like this, something was happening on the far side of the world that had nothing whatever to do with it, and everything to do with the age we now live in. A piece of rock from space, perhaps 10 kilometers across, came down out of the sky into a shallow sea off what is now the coast of Mexico. The impact ended an era. Within a span that counts in deep time as a single bad afternoon, something like 3 out of every 4 kinds of living thing on Earth were gone. And among them went the dinosaurs, every great reptile that had held the land and the sea and the air for 150 million years. Sit with the coincidence, because it is almost too large to be one. 2 of the most violent events the planet has produced in 100 million years, a continent on fire and a strike from the sky, fell within a whisker of the same moment on opposite faces of the world, with no link between them that anyone has ever found. India was burning while the dinosaurs were dying, and the eruption was not a single act tied to that one terrible day. It ran on in pulses for a long time before and after, indifferent to the ending it happened to share the calendar with. It could not have poured out all at once. The earth could not sustain such a thing. It came instead as a long series of titanic pulses stretched across something close to 1 million years, with quiet centuries in between when the lava cooled and life crept back over the fresh black rock, only for the ground to split open and bury it once more. Some single flows were so vast that one outpouring could cover an area the size of a small country and run 500 kilometers from its source before it finally stopped moving and began to harden. Layer settled onto layer this way, each one the record of a single catastrophic episode, until the stack stood kilometers deep. If you have ever seen the Western Ghats, the long green wall of mountains that runs down the western edge of India, wringing the rain out of the monsoon, you have seen the edge of that stack, the cut face of hundreds of lava flows laid one on another. The whole stone history of the eruption opened to the air. None of it was India's fault, if a continent can have a fault. India was simply in the wrong place. Far below the moving land, rooted deep down near the boundary of the Earth's molten core, a vast column of hot rock had been rising for ages, a mantle plume, a fixed fountain of the planet's interior that stayed put while the crust slid over the top of it. As India drifted north across this hidden flame, the plume burned up through the underside of the continent and flooded its surface with melt. And because the plume held still while India kept moving, it did not stay beneath the Deccan. It cut a line. Draw a path south from western India across the floor of the Indian Ocean today, and you will trace a chain of drowned ridges and sunken banks running like a long scorch mark across the sea. The Laccadive Islands, the Maldives, the Chagos Rise, each one older than the next, each marking a place where this same plume once broke through as India slid by overhead. Follow the line to its far end, and you arrive at a small, steep, still-burning volcanic island in the Southern Ocean called Réunion. The fire that flooded India never went out. India simply moved on and left a trail of cooling islands behind it to mark exactly where it had been. As for which of the 2 catastrophes actually finished the dinosaurs, the asteroid, the volcano, or the 2 of them in some grim partnership, that is an argument the science has been having for 40 years, and it is not yet over. The most careful dating we have shows the Deccan erupting on both sides of the impact, breathing out climate-bending gases for a long stretch before the asteroid arrived and a long stretch after. So perhaps the volcanism had already worn the living world thin, and the impact was simply the blow a weakened world could not survive. Or perhaps the asteroid did nearly all of it, and we keep reading too much into a coincidence. The honest answer is that we still do not know, and careful people land on different sides of it. What is not in doubt is that India, down in the Southern Ocean, was one of the 2 great furnaces burning at the hinge of that lost world, and that it went on moving north through every minute of it. It is worth holding for a moment how strange all of this is. We carry an instinct that a continent is the very definition of solid ground, the steady thing, the floor that holds still while the world moves across it. And here is a continent doing none of that. It is racing north across an open ocean faster than any landmass before or since. Along its western flank, it is splitting open and flooding the country with fire. It is breathing poison into the sky and tilting the weather of the whole planet. The most settled, dependable object you can picture, the ground beneath your feet, was behaving for those few million years like something thrown and burning, a piece of the world hurled across the world with its underside ablaze. And the whole time, it was carrying life. For all the violence on its surface, India through those long years of the crossing was never a dead place. It stayed an island the size of a country, drifting alone, with its own forests and rivers and creatures living out their days in the green country between the lava flows. And somewhere among them, on some ordinary morning, a single bead of resin would slide down the bark of a tree and close without hurry around an insect, beginning to harden into a small amber tomb that would keep that one forgotten dawn intact for 50 million years. The burning continent was also a living one, and the life it carried, sealed off on its lonely raft for so long, was quietly becoming something the rest of the world had never seen. For tens of millions of years, the strangest thing about India was the silence around it. Not silence on the island. Its forests would have been loud enough, full of insects and frogs and the calls of creatures long since gone. The silence was around it. There was no other land within reach in any direction, no coastline on the horizon, no chain of islands to step across, no slow traffic of animals wandering in from somewhere else or off to anywhere new. Whatever had been aboard when the continent first pulled free of the south was, more or less, all there would ever be. And on a drifting world like that, with no one watching and nowhere to go, life does what life always does when it is left alone with itself long enough. It begins to go its own way. We have a name for what happens when a piece of land is cut off like this. We call it an island fauna, and there are living examples to learn from. Madagascar with its lemurs, Australia with its pouched mammals, New Zealand with its flightless birds, each a world that went strange in its own fashion once the sea closed around it. Drifting India was an experiment of just this kind, run for an enormous stretch of time, and then ended as none of those others were, by arrival. Most of what it carried is gone now, ground away by the collision and the long ages since. But a few of its passengers are still alive, tucked into the wet hills of southern India, and they are among the quietly astonishing animals of the earth. There is a frog there, the purple frog, people call it, a squat, glossy, faintly comic thing about the size of a fist, with a pointed snout and small, wary eyes, which spends nearly its whole life underground and surfaces for only a week or two each year when the monsoon breaks, to breed in the swollen streams before vanishing back into the soil. It was unknown to science until 2003. A sizable animal, a whole branch of the frog family tree, hiding in plain sight in a region people had farmed and walked for thousands of years. And when at last its DNA was read, it told a nearly impossible story. The purple frog's closest living relatives are not in India, and not anywhere on the Asian mainland. They are a small handful of frogs that live only on the granite islands of the Seychelles, almost 3,000 kilometers away across the open Indian Ocean. Sit with that, because the obvious explanation does not work. The frog did not swim there, it cannot survive a minute in salt water, and 3,000 kilometers of ocean is not a distance a frog crosses. Its ancestors did not raft over on a mat of weed. What happened is slower and stranger than any crossing. The two were never split by an ocean that opened up and forced them apart. The ocean opened beneath them. The purple frog and its Seychelles cousins are the last two branches of a single old lineage that was already living on the joined land of India and the Seychelles before the two tore apart, around 65 million years ago. The Seychelles kept some of those frogs and stayed behind. India kept the rest and bore them north across the world. The lineage itself is older still, well over 100 million years, older than the Indian Ocean in anything like its present shape. They are more than rare animals. They are living pieces of the breakup, two halves of one family still holding the outline of a vanished continent in their bodies. The frog has company in this. In the wet soil of northeastern India lives a caecilian, a limbless, burrowing amphibian like a great soft earthworm, whose nearest kin live only in Africa. The two lines parted something like 140 million years ago, when India and Africa were still one. In the southern hills there are small, blunt, burrowing snakes whose closest relatives are far off in Southeast Asia. A pattern runs through all of it, and it is a quiet one. The animals that best remember the old broken world are nearly all diggers. Frogs that will not leave the wet ground, worm-like amphibians, snakes that tunnel, creatures that cannot swim a straight or cross open country, and so could only ever have arrived where they are by riding the land itself. A burrower makes a poor traveller, which is exactly what makes it a good witness. A bird mostly tells you that it could fly. A frog that cannot leave the soil tells you, with real authority, that the soil was once somewhere else. Not everything India carried was a leftover from the deep past, though. Some of it was busy becoming the future, and there is one extraordinary window onto that world. In the coal mines of Gujarat in western India, miners cutting lignite have turned up lumps of fossil tree resin about 52 million years old, and the resin is crowded with life. More than 700 insects and other small creatures have been lifted out of it. Ants, termites, bees, spiders, flies, a whole miniature world caught mid-gesture. The amber is so young by geological standards and so little altered that researchers can dissolve it gently and draw the insects out whole, their wings and legs intact after 50 million years. And the resin carries a message in the kind of tree that made it. A family of giant tropical hardwoods called the dipterocarps, the very trees that to this day raise the canopy over the rainforests of Southeast Asia. So if you had walked that Eocene shore in Gujarat, you would not have found yourself in some alien place. You would have been walking through a rainforest you half know, tall dipterocarp trees, dim green light, the drip and hum of the wet tropics. A jungle already 52 million years ago, doing very nearly what the forests of Borneo and Sumatra are doing tonight. The same rocks hold something stranger than a familiar forest, the bones of the first modern animals. Alongside the amber, those Indian mines have given up some of the oldest primates known from anywhere on Earth, small, large-eyed, tree-dwelling things near the very base of our own family tree, and the oldest bats yet found anywhere in Asia, already flying, already hunting more than 50 million years ago. And one animal in particular has made paleontologists look at India with new eyes. Its name is Cambytherium, a stocky, blunt-toothed plant-eater, somewhere between a large pig and a small tapir that browsed those forests around 54 million years ago. What makes it matter is its family. Cambytherium is the closest known relative of the perissodactyls, the odd-toed hoofed animals, the line that today runs to horses, rhinoceroses, and tapirs. It is not quite their ancestor. It sits just off to the side, a cousin rather than a forebear. But its presence here, in India and nowhere else, at exactly the right early moment, hints at something that would once have sounded absurd. That the lineage which led to the horse may have taken its first steps here, on the drifting island, before walking out into the wider world the moment a way opened. And here the story turns, in a way worth being honest about, because it unsettles the lovely picture of a sealed lifeboat. If India had truly been a closed world for all those millions of years, its life should be deeply ingrown, full of strange Gondwanan things, marked everywhere by its African beginnings. Some of it is exactly that. The frogs and the caecilians say so, but much of it is not. When researchers looked hard at the insects in that Gujarat amber, the surprise was where their nearest relatives lived. Not in Africa, the continent India had broken from, but scattered across the northern world, in the ambers of the Baltic, in the rocks of Europe and Eastern Asia. India, supposedly adrift and alone, had somehow already been trading life with the lands to its north. The arc, in other words, was leaking. Even with open sea still on the map between them, animals were finding their way between India and Asia, most likely across chains of islands and volcanic stepping stones that have since slipped beneath the waves. India was never quite the sealed vessel the neat version of the story wants. It was something better, a world half cut off and half connected, carrying the relics of where it had come from while it quietly began trading with where it was bound. For all of it, though, the experiment was running out of time. The whole while these forests grew and these animals lived out their days, the island beneath them never stopped moving, still pressing north a few centimeters a year into a sea that was steadily narrowing. Somewhere ahead, beyond the last of the open water, lay the underbelly of Asia, drawing closer by the slow arithmetic of the drift. And the ocean in between, the sea India had been crossing for 100 million years, was almost gone. It had only one age of its life left to live, and it was about to be swallowed whole. Where does an entire ocean go? It is not a question we are built to ask. Oceans to us are the very picture of permanence, the Atlantic, the Pacific, the great unchanging blue that has lapped the same coasts for the whole of human memory. But human memory is a thin sliver of time, and on the scale this story works in, an ocean is no more permanent than anything else. Oceans are born, they widen, they grow old, and they die. And the one India had spent 100 million years crossing, the Tethys, the sea that had lain between the southern world and the northern one since long before India set out, was, by the moment we have reached, a dying ocean. Within a few million years it would be gone. It did not merely shrink or dwindle to a landlocked sea. It vanished, closed, consumed, wiped from the surface of the earth as if it had never been there at all. The question worth sitting with is how? How do you make an ocean disappear? Hold its size in mind first, because the Tethys was no narrow channel. It was a true ocean, thousands of kilometers of open water, with its own deep basins and remote islands, its own currents and storms, and a sea floor that had been quietly gathering the rain of the dead, the shells and skeletons of countless small sea creatures drifting down through the dark, for tens of millions of years. India had been sailing across the southern half of it for an age, and Asia sat on the far northern shore. And the floor of that ocean was the very thing that carried India north, and the very thing that would have to disappear before the two continents could ever meet. Here is the strange truth at the heart of how oceans die. The floor of an ocean does not last. The rock of the deep sea floor, dark, dense, heavy stuff, far heavier than the granite of the continents, is born at long undersea ridges where the planet's interior wells up, and from the day it forms, it begins to age and cool and grow heavier still, until it is denser than the hot rock beneath it. And then it does what any heavy thing does. It sinks. Along great cracks in the seabed called trenches, the old ocean floor bends downward and slides back into the depths of the earth, swallowed into the mantle it came from and melting away as it goes. This was happening all along the southern edge of Asia. The floor of the Tethys was being drawn down and devoured beneath the Asian margin, mile after mile of it, vanishing into the planet. And because the floor was disappearing into that trench faster than new floor could be made to replace it, the whole ocean was shrinking, not from the middle, but pulled in from its leading edge, like a tablecloth dragged slowly off the end of a table and down out of sight. It is worth dwelling on why this matters, because it sets up everything that follows. The floor of the sea can vanish this way precisely because it is heavy enough to sink. A continent cannot. The rock that continents are built from is light, too buoyant to be hauled down into the mantle and lost. So as the Tethys narrowed and India came on, the ocean between the two continents was steadily eaten away at the trench, the seafloor diving down and gone, while the continents themselves rode high and refused to follow. The day would come when there was no ocean floor left to consume, when the last of the Tethys had been pulled under, and the leading edge of India arrived at the very trench that had been swallowing the sea. And a continent arriving at a place built to swallow ocean floor does not go quietly down, it jams. But that is a moment we are not quite at yet. When an ocean closes like this, it leaves a scar. The two continents carried together do not merge into one seamless block. They meet along a line, a join, and that join can be found and walked to this day. It runs in a long, ragged seam across the high country of southern Tibet, and for much of its length, two great rivers trace it. The Indus, which gathers in the west and runs down into Pakistan, and the Yarlung, which flows east across Tibet before turning south to become the Brahmaputra. Both rivers for long stretches run right along the line of the old join because the rock there is broken and weak, ground to rubble where two continents were welded together, and water always finds the weakness. Geologists call this line the suture. On one side of it lies rock that was once part of India. On the other side lies rock that was once part of Asia. And caught in between, pressed and tilted and stranded along the seam, are the remains of the ocean that used to lie between them. Those remains have a name too. Ophiolites, and they are the heart of this whole chapter because they are the dead ocean itself, lifted up and set down on dry land. Here and there along the suture, where the closing crush happened to shove pieces of the seafloor up onto the continents instead of dragging them under, you can find slices of the Tethys floor laid out in the open air, 4,000 meters and more above the waves they formed beneath. And they are unmistakable for what they are. Stand on one of them, and people do. There are places in Ladakh and southern Tibet where you can walk out onto this rock and look at what is under your boots. There are pillows, dark, rounded lobes of basalt, stacked and slumped together, each one formed when molten lava erupted not into the open air, but into deep, cold seawater, chilling so fast on the outside that it bulged into these soft, pillowy shapes before it hardened. There is chert, fine, hard, often a deep, rusty red, made almost entirely of silica, the microscopic, glassy skeletons of plankton that lived in sunlit surface water died and drifted down through kilometers of darkness to settle, grain by grain, on the abyssal floor. You are standing, in other words, on the floor of a sea, pillow lava that cooled under deep water, the slow snow of dead plankton turned to stone, the bottom of an ocean that no longer exists anywhere on Earth, and it is dry and cold and 4,000 meters up in the thin mountain air, with not a single drop of that ocean left. There is even a way to read its very last days. Above the ophiolites in the rocks along the suture lie the youngest marine sediments the Tethys ever made, beds of seafloor mud and limestone laid down in the final shrinking remnant of the sea, full of the shells of the last creatures ever to live in it. The newest of them are around 50 million years old, and after that, in those rocks, the sea simply stops. The marine beds give way to the muds of rivers and the dust of dry land, because by then there was no more sea there to lay anything down. That thin boundary where the ocean's record runs out is the closest thing the Tethys has to a death certificate, the precise layer, in the stone, where an entire ocean ran out of floor and ceased to exist. Everything above it was laid down on the ruins of a sea by a world that had already forgotten the sea was ever there. Somewhere in all of this, as the last of the Tethys drained away and the leading edge of India closed the final gap, the two continents touched. After 100 million years and the better part of 6,000 kilometers of open water, India arrived. You might imagine that such a moment, the meeting of two continents, the death of an ocean, the first faint stirrings of the highest mountains on Earth, would be the easiest thing in this whole story to date. A clean line in the rock, a clear before and after. It is the very opposite. The instant India first touched Asia is the single most argued over moment in the entire history of the collision. Lifetimes of careful work have gone into pinning it down, and the honest answer, even now, is that we cannot. Not to within 30 million years. The largest collision the planet has staged in 100 million years, and we still cannot say for certain what age it began, and the reasons for that turn out to be every bit as strange as the fact of it. Consider what we can measure. We can survey the mountains India raised and give you their height to the meter. We can read the frozen compass in a chip of Indian basalt and tell you, to within a few degrees, where the continent stood 80 million years ago. We can trace its whole 6,000-kilometer path north and clock the speed at which it traveled. We can stand on the floor of the ocean it closed and hold the last of that sea floor in our hands. And yet, after a century of brilliant, patient, often heroic work, there is one simple question about all of it that we still cannot answer. Not with confidence, not even close. We cannot say when it happened. The published estimates for the moment India first met Asia range across more than 30 million years, from around 65 million years ago to around 34. That is not a small disagreement at the edges of a settled figure. 30 million years is longer than the entire history of our own genus, several times over. It is a gap you could fit the whole age of the Himalaya into, with room to spare. The single largest collision on the face of the planet, and we cannot tell you what age it began. You would think the answer would be written plainly in the rock, and in a sense, it is. The trouble is that the rock gives several different answers at once. Along the suture, where the ocean closed, the clues are everywhere, and they are real, and they do not line up. The youngest seafloor sediments, the last beds the dying Tethys ever laid down, give one date. The sea was still there, in places, around 50 million years ago. The first grains of distinctly Asian rock to wash south and settle on the Indian side, the first sign that the two shores had drawn close enough to shed debris onto one another, show up earlier, in one much-studied section of southern Tibet, at around 59. The frozen magnetism in the rocks, read for the old latitudes of the two continents, gives its own answer, which matches neither perfectly. Each of these is a careful measurement made by careful people. Each points to a real event, and they disagree, because they are not all measuring the same thing, and that, it turns out, is the crux of the whole problem. But there is a deeper puzzle beneath the dates, and it is the one that really breaks the simple story open. It comes down to a single stubborn accounting problem, a vast quantity of rock that has gone missing. Since the collision began, India and Asia have moved toward each other by an enormous amount. The best estimates put it at around 3,600 kilometers of convergence, the two continents driven into one another across that staggering distance. Now, rock does not compress like a sponge. When you push two continents together by 3,500 kilometers, that crust has to go somewhere. Some of it clearly went up, crumpled and stacked into the mountains and the high plateau, the visible wreckage of the impact. But when geologists carefully add up all the crust they can actually see folded and thickened in the Himalaya and Tibet, the books do not balance. The mountains account for only about half of the convergence. The other half, something like 2,000 kilometers of continental crust, a slab the width of a continent, is simply gone. It is not in the mountains. It is not anywhere we can point to on the surface, and an entire science has spent decades trying to work out where it went. There are, broadly, 3 answers on offer, and the argument between them is the argument over the date. The first is the most direct. The missing crust went down. Continental rock is light, as we've seen, too buoyant to sink easily, but if you shove enough of it at a subduction zone, hard enough for long enough, some of it may be dragged down into the mantle after all and lost, swallowed into the depths along with the ocean floor that led the way. By this reckoning, perhaps half of India's original leading edge has simply been consumed by the planet, and the collision is more or less a single, long, grinding event that began around 55 million years ago and has never stopped since. The second answer is stranger, and it dissolves the problem in a different way. What if the crust that's missing was never solid continent at all? In this view, the India that first reached Asia 50-odd million years ago was not the whole continent, but only its thin leading sliver, a long stretched-out ribbon of Indian crust, with a hidden basin of ocean behind it, separating that ribbon from the main body of India, still coming up from the south. The first collision, then, was a soft one, a slender outrider of India brushing against Asia. The real, full-bodied collision, the main mass of the continent arriving, came tens of millions of years later, perhaps as recently as 25 or 20 million years ago, once that hidden basin had been swallowed in its turn. On this picture there is no single collision to date at all, but 2, separated by an age, and most of the missing crust is simply a vanished sea that no one was ever there to see. And the third answer says the first thing India ran into was not Asia at all, but a chain of volcanic islands stranded out in the open ocean, that India collided with this arc first, well before it ever reached the true Asian shore, and the final welding of continent to continent came later still, near 34 million years ago. You'd be forgiven somewhere in the middle of all this for wanting someone to simply tell you the answer. But that is precisely the point. There may not be a single answer because there may not have been a single event. This is the resolution, such as it is, and it is a humbling one. The question, when did India collide with Asia, sounds as though it ought to have a clean answer, a date you could carve over a doorway. But the question hides a swarm of smaller ones, and they have different answers. When did the first thin sliver of India brush the first island? When did the youngest sea floor between the two finally dry to land? When did the main body of the continent jam home and the mountains begin to rise in earnest? Those are different moments, possibly tens of millions of years apart. The 30 million year spread you find in the textbooks is not a sign that the science is broken, it is a sign that the science is being honest, refusing to flatten a genuinely tangled event into one tidy number just because a tidy number would be easier to carry around. The collision that raised the roof of the world is still being weighed, still being argued over, still giving up its evidence one stubborn fragment at a time. It does not yet have a birthday. It may turn out never to have had just one. But step back from the argument over dates, and one thing about all 3 of those stories is not in doubt at all. Whatever the missing crust did, whether it sank into the mantle, or hid in a vanished basin, or tangled with a drowned chain of islands, a great deal of it did not disappear. It went up. The half of the convergence the mountains do account for is the half we can see and stand on and climb. Thousands of kilometers of crust that had nowhere left to go but the sky. The dating may be unsettled, but the rising is not. Whatever the exact year, the crust had finally run out of room. No more ocean to swallow, no more space to give way. And when crust runs out of room, there is only one direction left for it to go. The making of the mountains is the story of that going up. Stand still for a moment and give a thought to what is underneath you. Whatever floor you are sitting or lying on rests, in the end, on the Earth's crust, the cool, brittle, outermost skin of the planet. Under most of the continents, that skin is about 35 kilometers thick. It sounds like a lot, and on a human scale it is unimaginable. You could stack 40 of the tallest buildings ever raised, one on another, and still not reach the bottom of it. But measured against the whole Earth, the crust is astonishingly thin, about as thin in proportion as the skin on an apple. It is the slimmest of layers, floating on the hot, slow-churning rock beneath. And the entire story of how the highest land on Earth came to exist is, at bottom, the story of what happens to that thin skin when you take two continents and drive one of them, with the unstoppable patience we have been following all along, straight into the other. The popular picture of how that goes is roughly the one we hold for a car crash. Two great masses meet head-on, crumple at the point of impact, and pile up a ridge of wreckage along the join. It is a natural image, and it is almost entirely wrong. India did not strike Asia and come to rest, the way a car strikes a barrier and stops. India is still moving. It has never stopped. What happens instead is stranger and more interesting. Where the two continents meet, the leading edge of India does not pile up against Asia, it dives beneath it. India is the lower slab. It slides under, wedging its way down and forward beneath the southern margin of Asia, lifting and thickening everything above it as it goes. The geologist's word for this is under-thrusting, and once you have the picture of it, the mountains begin to make a different kind of sense. Think less of two cars and more of a thick rug shoved hard against a wall. The rug has nowhere to go, so it buckles and rides up over itself, folding into a heap of stacked layers far thicker than the rug ever was lying flat. India is the rug, Asia is the wall. And within the Himalaya themselves, the same thing repeats at a smaller scale. The crust sliced by a row of great faults, the slices shoved up and over one another from the south like a deck of cards pushed together from one end, each card riding up the back of the one in front. And the result is doubled, in the most literal sense. Drill down into Tibet today, or read the deep crust with the echoes of distant earthquakes, and you find something that ought to be impossible. The crust there is not 35 kilometers thick, but something close to 70. It is, in places, twice the thickness of normal continental crust. 2 continents worth of rock, India's wedged beneath Asia's, stacked into a single colossal pile. It is one of those facts that quietly rearranges your sense of the ground. The rock beneath Tibet reaches down twice as far as the rock beneath your own feet. If you set out to dig a shaft straight down to the soft mantle below, the molten engine of all this movement, you would have to dig twice as deep under the Tibetan plateau as you would under almost anywhere else on Earth. The highest place on the surface is also hidden from view, the deepest. Far more of its rock lies below the surface than above it. There is one more thing that sets this collision apart, and it is the reason it produced not merely a mountain range, but a plateau. Most collisions between continents raise a range, a long, narrow welt of high ground, a line of mountains a few hundred kilometers wide at most. The Himalaya are exactly that, a wall along the southern edge. But behind the wall lies something far stranger. The whole of Tibet, an area of around 2.5 million square kilometers, comparable to the size of Western Europe, has been pushed up to an average height of nearly 5 kilometers and simply held there, a vast tableland in the sky, the largest expanse of high ground anywhere on the planet. And it is high not because it is propped up from beneath, but because of that doubled crust. Thick crust floats high, the way a thick raft of wood floats higher than a thin one. The deep crustal root beneath Tibet, the 70-kilometer keel, is what holds the plateau aloft. The mountains and the plateau are not balanced on anything. They float, buoyed up by their own enormous thickness, riding high on the mantle the way an iceberg rides on the sea, most of their mass forever out of sight below. There is a tidiness to that picture, though, that the real Tibet does not quite honour, and it is worth saying so. We tend to imagine the plateau rising all at once, the whole tableland heaved up to its present height in a single act. It did not happen that way. The plateau grew the way a wave grows, building outward and unevenly across tens of millions of years, with different parts of it rising at very different times. The mountains along the southern edge seem to have stood high quite early, soon after the collision began. But the heart of the plateau, central Tibet, tells a more surprising story. The rocks there preserve, well into the warm Eocene world, a low-lying valley running east to west across what is now the high, cold center of the plateau, a green subtropical lowland, barely a kilometer or two above the sea, where palms grew and the air was soft. That central valley did not climb to the height of a plateau until many millions of years later, in the Miocene. For a long stretch, in other words, the roof of the world had a warm green basin sunk into the middle of it, and exactly when and how the whole thing finally rose to the bleak heights it holds today is still being worked out, valley by valley, fossil by fossil. For all the unevenness, though, the direction of the whole vast process was upward, crust folding onto crust, slice riding over slice, the doubled pile rising into thinner and thinner air. And at the very top of it, at the highest point the rising ever reached, sits the strangest detail of all, the one we began this whole journey with and have been circling back toward ever since. The single highest place this collision lifted into the sky is not the granite root of a continent, nor a stacked slice of the Himalaya. It is the floor of the ocean we watched disappear. The pale marine limestone at the summit of the world rode up on the very crest of all this folding, a piece of dead seabed, carried higher than anything has ever been carried and left at the very top of the world. That summit is stranger than its reputation. What it is made of, how high it truly stands, and whether it is even the highest place it appears to be, all of that is worth looking at closely, now that we finally know how it got there. The rock at the very top of Mount Everest is more than 450 million years old. The mountain it sits on is, by the most generous reckoning, around 50. So the stone at the summit is older than the summit by something like 400 million years, and it did not begin its life as a mountain at all. It began at the bottom of a warm, shallow, sunlit sea on a quiet stretch of seafloor that lay at the time near the equator and well below the waves. The continents then were still mostly bare rock. There were no forests, no animals on land at all, no fish with jaws, nothing alive you would easily recognize. The Ordovician world that stone belonged to is so deep in the past that it is hard to hold in the mind. A time before trees, before backboned animals had crawled out of the water, before almost everything. And the floor of that long-vanished sea is now the single highest point on the surface of the earth. You can see its origins in the rock itself if you get close enough. The summit limestone is full of the dead, not the dramatic dead of dinosaurs and great beasts, but the quiet, countless dead of a shallow tropical sea. The broken stems of sea lilies, delicate animals that once stood anchored to the sea floor on long stalks and filtered the water with feathery arms, the scattered plates of trilobites, the rubble of small-shelled creatures that lived and died on that bottom and were buried in its lime mud. Climbers have been carrying chips of it down off the mountain for 100 years. On the famous expedition of 1924, the one on which George Mallory and Andrew Irvine walked up into the clouds near the summit and never came back, the team's geologist, a careful man named Noel Odell, read the high rock for exactly what it was: the floor of an ocean, lifted into the sky. The very topmost stone, The rock of the summit itself was confirmed to be the same marine limestone only later, when other expeditions brought pieces of it down from the highest few meters on Earth. But the answer was always there in the stone, waiting, just as it had waited at Wegener's coastlines and in Irving's magnetized basalt. The highest place on the planet is the floor of a sea. As for how high it stands, the number has a small drama to it. The figure China and Nepal agreed on, after a joint survey in 2020, is 8,849 meters, measured, remarkably, to the centimeter. A little under 8.5 kilometers, or 5.5 miles, of mountain standing up into air so thin that a climber near the top draws in barely a third of the oxygen they would at sea level. But the more striking thing about that number is that it is not final. Everest is still growing. The collision that raised it has never let up, and the mountain is still being pushed upward by a few millimeters a year, slowly, unevenly, and not without argument over exactly how fast. Some of the lift is the steady shove of India still driving north. Some of it, recent work suggests, is subtler. As the great rivers nearby carve away the rock around the mountain, the land, lightened of all that weight, rebounds upward, the way a boat rises when its cargo is unloaded, nudging the summit a little higher still. Either way, the figure on the maps is a snapshot of a moving thing. Everest today stands taller than it did when those surveyors set their instruments on it, by a sliver, but truly. And here, the mountain's reputation needs a little honest trimming, because Everest is the highest mountain on Earth in only one particular sense, and that sense is more arbitrary than it sounds. Everest is the highest point above sea level. That is a real and useful measure, but sea level is a human convention, a line we draw around the planet at the average height of the oceans. Measure the world another way, and Everest loses its crown. The Earth is not a perfect sphere. It spins, and the spinning makes it bulge at the equator, so that the planet is some 20 kilometers wider around the middle than it is from pole to pole. The point on the surface that reaches farthest from the Earth's center is therefore not Everest at all. It is a mountain called Chimborazo in Ecuador, sitting almost on the equator and riding high on that bulge. Its summit reaches more than 2 kilometers farther from the center of the planet than Everest's does, though it stands far lower above the sea. And if you measure mountains not from sea level but from their true base, the tallest is not Everest either, but Mauna Kea in Hawaii, which rises more than 10 kilometers from the deep ocean floor it stands on, most of that height hidden underwater. So the simple claim that Everest is the highest mountain on Earth turns out to rest entirely on one particular ruler. By that ruler, it wins. By others, it does not. And by no ruler at all is it finished. Put all of it together and stand for a moment where almost no one ever does. You are at the top of the world, in the bitter cold and the terrible thinness of the air, 8.5 kilometers above the sea. Under your boots is pale grey limestone. In that limestone, if you brushed away the rime of ice and looked closely, are the small ringed stems of animals that lived on the floor of a tropical ocean before there were trees, before there were spiders, before anything at all had walked on land. You are standing on the bottom of a sea that died and was carried up into the sky, the floor of a vanished ocean lifted to the roof of the world. And it is not still. Even now under your feet it is rising, a fraction of a hair this year and a fraction the next, and on, because the slow collision that hauled this seafloor all the way up here has not, even slightly, finished its work. And the mountain is only the edge of it. Turn your back on the long drop into Nepal, look north across the top of the Himalaya, and what lies beyond is not more peaks, but a strange, flat, brown immensity, the Tibetan plateau, the great tableland we have spent so long building, stretching away for 2,000 kilometers and held up nearly 5 kilometers in the sky. It is so high, and so vast that it behaves like a piece of some other planet. Across its cold heights, it has gathered the largest store of ice and fresh water anywhere on Earth outside the two polar caps, so much that it has earned a third name to set beside the Arctic and the Antarctic, the third pole. From its glaciers and its frozen ground run the headwaters of the greatest rivers in Asia, the Indus and the Ganges, the Brahmaputra, the Yangtze, the Yellow River, the Mekong. The water that falls and freezes and melts on this one plateau reaches in the end the fields and the cups and the throats of close to 2 billion people. But the most far-reaching thing these risen mountains ever did was not simply to stand there, being the highest land on Earth. It was to get in the way of the sky. Here is a barrier of rock and ice, the highest and broadest the planet has ever thrown up, set squarely across the belly of a continent. And every year, off the warm ocean to the south, a vast tide of wet air comes sweeping north and runs straight into it. What does a wall 5 miles high do to the sky that breaks against it? The answer is one of the largest things this whole collision ever made. Not a mountain and not a plateau, but a season, a rhythm of rain that close to 2 billion lives now turn on. Having risen, the mountains began to make the weather. By the second week of June, on the plains of northern India, the land is at the end of its patience. For months it has been baking. The soil has cracked into a mosaic of dry plates. The rivers have shrunk to threads in their wide, pale beds. The air over the fields shimmers and presses down day after day at temperatures that climb past 45 degrees. People sleep on rooftops to catch whatever stirs of the night air. Animals stand in whatever shade they can find. And the whole country leans into a single question, asked in 100 languages and a billion private thoughts: when will it break? And then one afternoon the wind changes. It has been blowing dry off the land for half a year, but now it swings around and comes up from the south, off the sea. And it is wet, and it is cooler, and it carries the smell of distant water. The sky to the south stacks up into towers of cloud. Somewhere, the first heavy drops strike hot dust and send up that particular smell that has no real equal, the smell of rain on parched ground. The monsoon has arrived. Within days, the whole subcontinent is under it. What has happened is, at heart, a simple thing made enormous. Air moves from where it is heavy toward where it is light, from cool places toward warm ones, and a monsoon is that movement run on a continental scale and turned by the seasons. Through the long summer, the great body of Asia heats up far faster than the ocean to its south. The warm air over the land rises, and into the space beneath it pours the heavy, moisture-laden air of the Indian Ocean, dragged northward across the whole subcontinent in a tide that does not let up for weeks. That air is wrung out as it travels, lifted, cooled, and emptied of its water in sheet after sheet of rain. Then, in winter, the pattern reverses. The land cools faster than the sea, the wind turns and blows dry and offshore, and the rains shut off as if a tap had been closed. The result is a country that takes in the overwhelming share of its water. In many places, 4/5 of an entire year's rainfall, in one drenching season, and then waits, parched, for it to come again. The whole of life there is built around the timing of that one wind. And the reason that wind is as strong as it is, the reason South Asia has one of the most powerful monsoons on the planet, rather than the milder seasonal rains many warm coastlines get, comes back once again to the mountains. But here the science gets genuinely interesting because we are not entirely sure how. The long-held explanation is that the Tibetan plateau works like a great radiator in the sky. A vast surface lifted 5 kilometers up into the atmosphere, soaking up the summer sun, heating the air directly, and pumping the whole circulation harder. That may well be right, but over the last 15 years or so, careful modelling has suggested something subtler. In this newer view, what matters is not so much the plateau's heat as the Himalayan wall itself, not as a heater, but as a fence. The mountains stand as a barrier high enough to block the cold, dry air of inner Asia from spilling south and smothering the warm, wet air gathering over India. By walling off the cold, they let the heat and the moisture pile up undisturbed on their southern side, and it is that trapped warmth, more than the plateau's own, that drives the rains. Is it the radiator or the fence? The honest answer is that we are still working it out, that one of the most consequential weather systems on Earth still keeps a quiet secret about exactly how its own engine runs. Either way, the thing to hold on to is this: the rains that soak the plains of India and Bangladesh every summer, the rains that fill the rice paddies and the rivers that an entire civilization orders its year around, are not simply weather. They are a consequence of the collision. There were monsoon-like rains in this part of the world before the mountains existed, but nothing on this scale. The great wet engine in its present strength is the work of the wall and the plateau that India's slow arrival pushed up into the sky, which means that close to a quarter of all the people alive depend for their food and their water on rains that fall because two continents ran into each other. The water that swells the Ganges and floods the fields of Bengal is, in a real sense, the exhaust of a slow-motion crash, and it reaches further than the fields. The same air, the same vast turning of the atmosphere touches weather far beyond India, so that on some warm night, in a place that has never heard of the Himalaya, the particular feel of the air may carry, faintly, the signature of a wall of rock 5 kilometers high, bending the breadth of half a planet around itself. How long has it been this way? That, too, is still being argued, and the argument has its own quiet drama. The most common account holds that the monsoon in something like its modern form switched on or sharply strengthened around 23 million years ago, as the plateau climbed toward its full height, with a further intensification near 8 million years ago, written into the rocks as a wholesale change in the plants of the region when older vegetation gave way to the tough tropical grasses that thrive on a hard, wet and dry rhythm. But other evidence, gathered more recently from fossils and ancient soils, reaches back much further and hints that monsoon rains were already sweeping this corner of the world in the late Eocene, perhaps 40 million years ago, in a warmer and higher carbon world, only to falter as the planet cooled and then return. The whole history is tangled together with the rise of the plateau, which we cannot date cleanly either, and with the slow swings of the global climate. The mountains, the rains, and the cooling earth turn out to be a single knot, and we are still working its threads apart, one buried leaf and one layer of old soil at a time. But step away from the dating and stand for a moment in the simple, lived fact of it. Across the whole of South Asia, the year is not really divided into the months of a calendar. It is divided into before the rains and after, the planting and the harvest, the festivals and the weddings, the price of grain, the level of the wells, whether a family eats well or eats thin. All of it hangs on a wind that turns or fails to turn on time. When the monsoon comes early or late, when it brings too little or too much, it is not an inconvenience. It is the difference for hundreds of millions of people between an easy year and a hard one. And every one of those people, whether they have ever once given it a thought or not, lives at the mercy of a season that exists because 50 million years ago, a continent finished crossing an ocean and ran aground against another. The most ordinary thing in their lives, the rain in its season, is one of the most distant consequences of one of the largest events in the history of the planet. There may be no clearer example anywhere of how deep time reaches all the way up into a single ordinary afternoon. There is one more thing rain does, though, beyond filling the wells and the paddies, something far quieter and stranger and only recently understood. Rain is not pure water. As it falls, it takes a little carbon dioxide out of the air and turns faintly acid. And when that mild acid lands not on a field but on bare mountain stone, it does not simply run off. It eats. Drop by drop, year upon year, the rain dissolves the rock of the freshly raised mountains, and in the chemistry of that slow dissolving, carbon is drawn down out of the sky and locked away. Take one raindrop on one stone and multiply it by the entire monsoon, falling on the largest, youngest, most rapidly crumbling mountains on Earth for tens of millions of years, and you arrive at one of the boldest and most contested claims in this whole story, that the rise of these mountains may not only have made the weather, but may have reached up and cooled the whole planet, and helped open the door to the age of ice that we ourselves were born into. Can a mountain range cool a planet? It sounds, on its face, like a category error, like asking whether a wall could change the seasons, or a river could shift the orbit of the Earth. A mountain is a local thing, a feature of one region. The temperature of the whole planet is a global thing, set by the balance of the entire atmosphere. The two seem to belong to different scales of the world. And yet there is a serious, decades-old idea in the earth sciences that says the answer might be yes, that the rise of the Himalaya and the Tibetan plateau may have reached up out of their corner of Asia and pulled down the temperature of the entire Earth by enough and for long enough to help tip the planet out of a hot and ice-free age and into the cycle of ice ages that has held it ever since. And if that idea is right, it carries a strange and intimate implication. The cool, restless, glacier-haunted world that you were born into, the only kind of world our species has ever known, may owe part of its character to a slow collision that finished long before there was anyone to feel the chill. We may, in a sense, be children of these mountains. The trouble is that no one is sure whether the idea is right. To see where it comes from, you have to know what the climate of the last 50 million years has actually done, because it has not held still. When India first drove into Asia, the Earth was a hothouse. There were no great ice caps anywhere on the planet. The poles were cool and forested rather than frozen. Crocodiles and palms lived in the high Arctic, and the deep oceans ran many degrees warmer than they do now. That was the world the collision began in, and then, slowly, unevenly, across the whole long age that followed, the planet cooled. The carbon dioxide in the air drifted downward from levels far above anything in human experience toward the thinner mix we know. Around 34 million years ago, the first permanent ice formed, sheeting over Antarctica. The cooling went on in fits and starts for tens of millions of years more until, only in the last few million, it tipped into the rhythm of the true ice ages. Vast northern ice sheets advancing and retreating over and over in time with subtle wobbles in the Earth's orbit. That is the climate our own kind evolved inside. The whole rise of humanity happened against the backdrop of an unusually cold, unusually unstable world. And the deep question is why the planet went there at all. Why, after 100 million years of warmth, the Earth turned cold. In the late 1980s, a small group of scientists, the names most tied to the idea are Maureen Ramo and William Ruderman, proposed an answer as audacious as it was elegant, and it is the one we have been circling all along. The key, they argued, is the chemistry we met a moment ago. Rain, made faintly acid by the carbon dioxide it carries, slowly dissolving rock and locking that carbon away. This kind of weathering happens anywhere there is rock and rain. But it happens fastest where the rock is fresh, the slopes are steep, and the rain is heavy, where mountains are young and rising and crumbling, and a monsoon is hammering at them daily. And there has been no greater engine of it in the whole of the last 100 million years than the Himalaya and Tibet. Ramo and Rudderman's proposal was that the rise of these mountains turned up the planet's rate of weathering so far and held it up for so long that it drew the carbon dioxide steadily out of the sky and the world cooled in step. A single mountain belt in this telling became a hand resting on the thermostat of the entire Earth. One raindrop on one stone multiplied across a whole young mountain range and 10 million years until the climate of the planet bent to it. It is a beautiful idea, and for a while it was close to the standard story. But the better the Earth sciences have come to understand the carbon cycle, the more trouble the idea has run into, and the trouble runs deep enough that the question is now genuinely open. The central objection is subtle and worth taking slowly because it turns the whole picture on its head. Silicate weathering, it turns out, is not a simple valve you can crank open to bleed carbon out of the air. It is a thermostat. The rate of weathering depends on temperature. Warm, wet conditions speed it up. Cold and dry ones slow it down. So if weathering ever pulled the carbon dioxide down far enough to cool the planet, the cooling itself would slow the weathering, and the drawdown would ease, and the system would settle back toward balance. The weathering does not so much drive the climate as stabilize it. To cool the Earth for tens of millions of years, you cannot simply weather harder. The thermostat pushes back. And there is a second, harder problem: the evidence itself. When researchers measure how fast the rivers draining the Himalaya have actually been weathering rock over the past several million years, they do not find a rate that rose as the world cooled. In several records, it fell. That is the opposite of what the simple story predicts, and it points the arrow the other way. It suggests the cooling climate slowed the weathering, rather than the weathering driving the cooling. There are other possible culprits too. Perhaps the planet was simply breathing less carbon dioxide out of its volcanoes than before, so the air thinned of it from the supply side rather than the demand side. The clean line that the Himalaya cooled the world and made the ice ages does not survive close contact with what we now know. So where does that leave us? Not with a tidy answer, it must be said, but not with nothing either. Almost no one doubts that the rise of the Himalaya mattered to the planet's chemistry in some way. Mountains this large, weathering this fast, burying this much rock and carbon in the sea, cannot have been irrelevant to the carbon balance of the world. The argument is not over whether the mountains played a part. It is over how big a part, and whether it was cause or consequence, whether these mountains pulled the world toward the ice or simply rode along as the world cooled for other reasons. And the honest position today is that we cannot yet say. The cooling of the Earth over the last 50 million years is one of the great events in the planet's recent history, the very event that set the stage for everything we are, and its deepest cause is still being worked out, and it is worth slowing down there rather than rushing past it. We would like the story to be clean, a single cause, a single hero, a mountain that cooled a world. The reality is humbler and in its way larger, a tangle of half-understood feedbacks operating across the whole face of the planet, in which a mountain range is one player among several and the truth is still out at the frontier, argued over by people reading rivers and rocks and the chemistry of long-vanished air. It may be that we are, in part, children of these mountains. It may be that we only flatter them. For now, we can hold both possibilities at once, which is not a failure of knowledge so much as an honest measure of how large the question is. Whatever the mountains did or did not do to the global thermostat, one thing is beyond doubt. The world did cool, and the high plateau they had raised grew colder than almost anywhere else, a frozen tableland thrust up into the thin, biting air. And on that cold roof of the world, long before the great ice sheets came grinding down over the northern continents, something was already living that had no business being there yet. Picture a particular morning on the high Tibetan steppe, around 3.5 million years ago. The grass is stiff with frost. The wind comes off the heights with teeth in it. And out of the white blur, head low, sweeping the snow aside to reach the grass beneath, comes a great shaggy beast that the world will not meet in its full glory for another 2 million years, a creature already dressed on this freezing plateau for an ice age that has not yet begun. Come closer and look at the animal properly. It is a rhinoceros, but not one you would know from any zoo or any African plain. It is built for the cold in every part. A thick double coat of shaggy hair hangs nearly to the ground, brown and matted, breaking the wind. The body beneath it is heavy and barrel-chested, low to the ground, hoarding its heat. And on the end of its long skull, it carries a strange tool. Not the upright spike of a modern rhino, but a great flattened blade of a horn, leaning forward, slightly curved, the kind of thing you might use to scrape or to sweep, which is, very probably, exactly what it does. When snow lies over the grass, this animal lowers its head and swings that flat horn across the ground like a plough, clearing the white away to reach the frozen forage underneath. It is a winter animal, perfectly equipped for a hard, cold, snow-locked life. And that is the strange part, because the world it is living in is not yet that kind of world. We know this animal exists because of a skull. In 2007, on the high, dry, fossil-strewn badlands of the Zander Basin, in the far southwest of Tibet, at the foot of the Himalaya, a team of paleontologists led by the Chinese scientist Tao Deng found a nearly complete skull and lower jaw weathering out of the ground, the skull of a woolly rhinoceros lying at over 4,000 meters of altitude. When they worked out its age, the number was startling. The rock it came from was around 3.5 million years old, which made this the oldest woolly rhino ever found, by a wide margin, older than the famous Ice Age woolly rhinos of Europe and Siberia, the ones that turn up frozen in the permafrost and painted on the walls of caves, by something like 2 million years. It sat at the very base of the family tree of its kind, not a side branch, but the ancestor, or something very close to it. It had been living, with its snowplow horn and its heavy coat, up on the cold plateau, 2 million years before the rest of its lineage would make those same features famous, out on the open tundra of the north. The team gave it a name that said where it came from, Coelodonta thibetana, the hollow-toothed beast of Tibet. That ordering of events, the cold adapted form appearing first up on the plateau and only later spreading out across the lowlands, is the heart of an idea the discoverers called out of Tibet, and it is one of the more elegant in all of paleontology. Here is the puzzle it solves. The great Ice Age beasts, the woolly rhinos, and alongside them the woolly mammoths, the giant deer, the cold-loving sheep and goats, seem to arrive more or less ready-made when the Ice Ages begin, already wrapped in their thick coats and built for the freeze. But evolution does not work on command. A coat like that, a body like that, takes a long time to assemble. You cannot grow one in the moment the cold arrives. So where had these animals been practicing? The answer Deng and his colleagues proposed was Tibet. The plateau, pushed so high by the collision, was already bitterly cold long before the rest of the world turned cold. One of the only patches of true winter on a planet that had not yet grown cold, a pocket of the future climate existing in a single place ahead of time. Up there, across millions of years, animals could evolve, in slow patience, all the equipment a glacial world would one day demand. Stand on that plateau 3.5 million years ago, and you would have been standing inside the only real winter on Earth, surrounded by creatures already adapted to a season the planet had not yet invented. Then, when the global cold finally came, the doors of the plateau swung open, and the animals that had been quietly perfecting themselves up in that high, cold cradle walked down off it and out across the newly frozen north, pre-built, pre-furred and ready for a world that had at last caught up to them. And the woolly rhino did not walk down alone. The Zander Basin and the rocks around it have begun to give up a whole lost caste, a roll call of Ice Age lineages, all of them appearing in Tibet earlier than anywhere else. There are early sheep and antelope, ancestors of the wild flocks that still cling to those heights. There is a small, fierce, wild dog, a relative of the dhole, and there is, most striking of all, a big cat. A skull from the same high badlands belongs to the oldest known member of the great cat family, the lineage that would one day give the world the tiger and the snow leopard, padding across the cold plateau before any of its descendants had reached a single other continent. The pattern repeats and repeats. The high country the collision had raised was not only a barrier and a rainmaker and a possible hand on the planet's thermostat. It was also a workshop, a place where, in the thin, cold air, the collision was quietly building a new kind of life, the cold-hardened animals that would inherit the frozen world to come. There is something about that rhinoceros on the frosted plateau 3.5 million years ago that is hard to walk past. It was, in the most literal sense, ahead of its time. Every feature that made it strange, the heavy coat it did not yet need everywhere, the snowplow horn for a snow that had not yet buried the world, was an answer to a question the planet had not finished asking. The Ice Age was still 2 million years off. The great northern ice sheets had not formed, the mammoth steppe did not yet exist. And here was an animal already shaped for all of it, grazing a frozen hillside as though it remembered a winter that was still in the future. We tend to think of adaptation as a kind of catching up, life forever a step behind the world it has to survive. And here, for once, was the opposite, life running slightly ahead, the cold weather animals already assembled and waiting up on the one cold corner of a warm earth for the rest of the planet to come round to them. There is a strange comfort in it. When the long winter finally fell, the world was not caught entirely unprepared. Something up on the roof of the world had already been getting ready, quietly, for 2 million years. But even as the plateau bred this new world of life across its surface, the surface itself was not safe. Pull back from the rhino and the cat and the high cold pastures, widen the view, and you begin to notice the rivers. They pour down off the plateau and out of the mountains in every direction, fast and grey and heavy, and they are not running clear. They are thick with the mountains themselves, with sand and silt and groundstone, the very substance of the high country, broken loose and carried away. The same uplift that built this whole world, that raised the wall and turned the monsoon and shaped the woolly rhino, set against itself from the very first day an equal and opposite force. The moment the mountains rose into the rain began to take them back down, and that slow taking down, where all the stolen mountain goes, and how the building and the unbuilding have been locked ever since, in a contest with no winner, turns out to be a story very nearly as large as the building of the mountains was. Stand in the Himalaya and look up at a peak, and you are, in a sense, looking at a ghost, at what is left of something larger. Because the mountain in front of you is not the whole mountain. Above the rock you can see where the summit now ends in thin air. There used to be more rock, kilometers of it, that once stood higher still and has since been stripped away and carried off. The peak is a remnant. The same holds everywhere you look in these mountains. Every ridge is a leftover, every valley is a wound, a place where a colossal amount of rock used to be and simply is not anymore. The Himalaya you can photograph are the survivors of a far greater mass of stone that has already been taken down off the heights and removed. And if you go searching for that missing rock, the lost upper kilometers of the highest mountains on Earth, you will not find it in the mountains at all. You will find it lying flat, in the dark, 1,000 kilometers away, on the floor of the sea. The thing taking it down is mostly water. These are the wettest, steepest, most violently weathered mountains on the planet, and they are under attack from the moment they rise. The monsoon dumps its rain on them. The rain runs off in rivers fierce enough to roll boulders along their beds. High up, water seeps into cracks in the rock, freezes overnight, and splits the stone apart with the slow, patient force of expanding ice. Whole hillsides let go in landslides. Glaciers grind the valleys deeper. The rivers carry the broken pieces away. Day to day, it does not look like much. But it never stops, and it works on everything at once, and across the long count of years, it strips away a staggering amount of rock, on the order, in places, of a millimetre a year off the whole face of the range, which sounds like nothing until you remember that a millimetre a year is a kilometre in a million years, and these mountains have been standing for 50. The picture to hold is a strange one. A mountain range on a kind of upward escalator, pushed steadily higher from below by the collision, and at the very same moment being sanded down from above, fast by the rain and the rivers and the ice, the building and the unmaking running together every single day. And where all of it ends up is one of the most astonishing and least known features on the face of the earth. The Ganges and the Brahmaputra, the two great rivers that drain the southern flank of the range, gather up the broken mountains and carry them, better than 1 billion tons of rock and mud every year, down to the Bay of Bengal, and there they let them go. Out across the floor of that bay and far beyond it, the sediment has been settling and piling up for tens of millions of years into a single enormous heap, the Bengal fan. It is the largest body of sediment anywhere on the planet. It runs some 3,000 kilometers from north to south, more than 1,000 from side to side, and in places it is 16 kilometers thick, a buried mountain range of mud and sand lying on its side beneath the Indian Ocean. And here is the thing worth pausing on. That fan is not merely made from the Himalaya. In a real and literal sense, it is the Himalaya, the same rock, the same range, simply taken apart grain by grain, carried south and laid back down flat. The highest mountains on Earth and the largest pile of sediment on Earth are the same object in two different states. One standing up, one lying down, with a river running endlessly between them, moving the one slowly into the other. You can see a smaller version of the same thing much closer to the peaks. The low, soft, jungly ridges that run along the southern edge of the range, the Siwalik Hills, look like an unremarkable foreground to the great summits behind them. But they are not foreign to the mountains. They are made of the mountains. The Siwaliks are the older debris of the range, the rock and mud worn off the high country in ages past, dumped at its foot, and then, as the collision rolled on, scooped up and lifted into hills in their own right, only to begin wearing away all over again. The mountains, in other words, are eating their own ruins and stacking them back up. And those recycled hills have turned out to be a priceless record, layer by layer, of the whole long history of the wearing down, the changing rivers, the shifting climate, the coming of the grasslands and the grazing herds, all of it written into the cast-off rubble of the heights. There are two places, at the very ends of the range, where the wearing down turns ferocious and concentrated, where, for once, the rivers are visibly winning. At the western end, near a peak called Nanga Parbat, and at the eastern end, where the great river the Tibetans call the Yarlung swings around a mountain named Namche Barwa, two of the largest rivers in Asia have soared straight down through the rising rock and cut gorges of almost unbelievable depth. The eastern one, the gorge of the Yarlung Tsangpo, is the deepest canyon on the planet, far deeper than the Grand Canyon, the river roaring along the bottom of a chasm whose walls climb 5 kilometers to the snow. The cutting there is so fast and so focused that it does something stranger than carve a valley. It draws the deep, hot rock of the planet's interior up toward the surface, the river acting almost like a wound that will not close, pulling the inside of the earth out into the daylight. These are the places where you can stand and watch, in the geometry of a single gorge, the whole contest of this chapter at once. The mountain straining upward and the river cutting down through it faster than it can climb. Step back from all of it, and a quiet truth comes into focus, one that runs against everything our instincts tell us about mountains. We treat them as the very emblem of permanence, old as the hills, solid as a rock, the things that outlast everything else. But the Himalayas are not permanent, and they are not even particularly old. They are young, and they are temporary, and they are dissolving in front of us, carried off to the sea a grain at a time. The only reason they are still here, still climbing, is that the collision has not yet stopped pushing them up faster than the rain can take them down. The day that pushing ends, and it will end when India finally comes to rest, the rivers will win for good, and these mountains will go the way of every mountain before them, worn down across tens of millions of years into low green hills, and then into plains, and then into nothing at all, spread out and buried beneath some future sea. Everything that has ever risen on this planet has come back down. The highest of all is simply taking its turn. And the next time you find yourself on a beach somewhere along the Bay of Bengal, letting the grey sand run through your fingers, it is worth remembering what you may be holding. The worn-down summit of a mountain that, for a few million years, touched the edge of the sky. And yet, for all the relentless taking down, the mountains are still here, still the highest on Earth, and still, this year, a little taller than last. The rain has been working at them for 50 million years and has not won, because behind the wearing away, underneath it, older and stronger and utterly tireless, the force that built them has never once let up. India is still moving. The collision is not a finished event we are looking back on from a safe distance. It is a live, ongoing, present tense thing grinding on beneath the surface at this very moment, under the cities, under the rivers, under the worn and rising peaks. And it is closer and stranger and more unsettling than the deep past has any right to be, because it is not only history, it is happening right now under our feet. Here is a fact to sit very still with. At this exact moment, tonight, wherever you are, whatever hour it is where you are listening, the subcontinent of India is moving into the underside of Asia. Not metaphorically, not in some figure of speech about the distant past. Right now, as you breathe, the great slab of the Indian plate is sliding north and pressing into the continent above it at a rate of roughly 4 centimeters a year. That is, near enough, the speed your fingernails are growing as you lie there. It is too slow to feel, too slow to see, too slow to make the smallest difference to a single day. But it does not stop. It has not stopped. Not for one human lifetime out of the whole long line of them, not once in 50 million years. Over the few minutes this chapter has been speaking, the highest mountains on Earth have risen by a fraction of a hair's width, but truly, the way they have risen every minute of every year since before there were people to watch. This is the part of the whole story most worth holding on to, and the part our language fights us on. We keep wanting to say that India collided with Asia, past tense, a thing that happened and finished. It is the wrong tense. India is colliding with Asia. The crash is not over. It is the slowest event you will ever be inside of, and you are inside of it right now. And we are not guessing at this. We can watch it happen. Bolt a high-precision satellite receiver to the bedrock of the Himalaya. There are hundreds of them now, scattered across the mountains and the plateau and the plains of India, and leave it there, year after year, listening to the satellites overhead and fixing its own position to within a few millimeters. Come back and read the record, and you can see the ground itself drifting, station by station, in a great slow current flowing north and crumpling against the mountains. The numbers come out clean and undeniable. Down on the plains of India, the land is moving north at the full 40-odd millimeters a year. Up and over the high Himalaya, that motion is steadily eaten away, squeezed out, absorbed into the rising of the rock, until on the far side of the plateau, the ground has nearly come to rest. The mountains are, quite literally, the place where India's northward rush is being brought to a halt, a few millimeters at a time, and turned into height. We are the first people who have ever lived who can read the whole collision straight off the instruments, live like a heartbeat on a monitor. And once you start looking, the live collision is everywhere in the present, not only on the instruments. The peaks are still gaining height. Everest a few millimeters taller with each passing year. The great gorges at the ends of the range are still cutting downward, the rivers still hauling the mountains away to the sea. Along the faults, hot springs steam where the deep heat of the crumpling crust leaks up to the surface. Roads and field boundaries laid out dead straight by surveyors a century ago have bent by measurable amounts as the ground beneath them crept and warped. The mountains are not a monument to something that finished long ago, a ruin we have come along afterward to admire. They are a work still in progress, a construction site the size of a subcontinent, where the building has simply been going on so slowly and for so long that we mistake the unfinished thing for a finished one. The ground does not always give way gently, though. Most of the time, along the great fault where India slides under the mountains, the two sides are not slipping smoothly at all. They are stuck. The rock is locked together, jammed by friction, while India keeps pushing from behind, and so the strain builds and builds, invisibly, year after year and century after century, like a spring being slowly wound. It cannot build forever. At some point, the lock breaks, the fault lets go, and decades or centuries of stored-up motion are released all at once, in a few seconds, as a great earthquake, the ground heaving, the mountains lurching upward by meters in an instant, the whole patient pressure of the collision spent in one convulsion. This is how the slow crash actually pays itself out, not as a steady creep you could watch, but in long silences broken by sudden, violent settlements of the account. And it is worth being honest that this is not only a spectacle of deep time. Some 2 billion people live on and around the leading edge of this collision, across northern India and Pakistan and Nepal and the lands beyond. And the great earthquakes the collision throws off have, through history, been among the most consequential events those people have ever lived through. The deep past here is not safely in the past. Every so often, it reaches up out of the rock and touches the present directly. For a great many people alive today, the largest event in the recent history of the planet is also the most local fact there is, the very ground beneath their feet, slowly, patiently, and once in a long while suddenly, on the move. But step back from the rare violence of the earthquakes, which are only the sudden punctuation, and return to the steady, silent truth underneath them. For the overwhelming majority of all the time there is, the collision is not a convulsion at all. It is the quietest thing imaginable, a slow, patient, ceaseless pressure moving a continent the width of a fingernail in a year and never letting up. And it is happening now, under everything, under the sleeping cities of the plain, under the rivers carrying the mountains to the sea, under the worn and rising peaks with their sea floor at the summit. And under you, wherever you happen to be lying as you listen to this, because the plate you are resting on is part of the same restless skin of the earth, joined through the rock to that slow northward grinding far away. You are not separate from it. You are lying on the surface of a planet whose continents are, at this very moment, in slow and silent motion, rearranging themselves across deep time exactly as they always have, and exactly as they always will. And the strange thing is that this is a comfort, not a fear, to feel, even faintly, the enormous patient machinery turning away beneath the stillness of a single quiet night. The collision is not something that happened to the world long ago. It is one of the things the world is quietly doing right now while you rest. And since it is still going, the natural question, the one a child asks and the one the science asks, is simply, where does it end? If India is still driving north, still pushing the mountains up, still grinding on under the cities and the dark, then what comes next? Give it 1,000 years, and almost nothing changes. The mountains stand a little higher, a fault somewhere has slipped, and the night goes on. But that is not the scale this story has ever worked at. Give it instead another 5 million years, and another after that. Run the clock forward by as much again as the whole collision has so far lasted, and the question stops being about these particular mountains at all. It becomes a question about the entire restless surface of the planet, and about a pattern far older and larger than India, one that was already turning long before these continents took their present shapes, and that will still be turning long after they have lost them. So widen the frame all the way, lift up off the Himalaya, off the single line of white peaks that has held our attention for this whole story, and pull back and back until that mighty range is only one wrinkle among many on the face of a whole planet. And then keep pulling back, not through space now, but through time. Let the millions of years run past like weather. Watch what happens to the mountains of the earth on that timescale, and a strange thing comes into view. They are not fixed features at all. They rise, and they wear down, and they vanish, and new ones lift somewhere else, over and over, in a slow, ceaseless churning of the surface. The map of the world's mountains is not a permanent thing you could learn once and keep. It is a single frame from a film, and the film has been running for billions of years, and it is still running now, and the Himalaya are just the shape it happens to be making at this particular moment, in this particular corner of the world. Begin with the near future. Near, that is, by the clock this story keeps. India is not going to stop tomorrow, or in 1,000 years, or in 1,000,000. It has momentum measured in the mass of a continent, and it will go on driving north into Asia for a long time yet, and the Himalaya will go on rising, but not forever. Eventually, in tens of millions of years, the forces pushing India will spend themselves. The last of its motion will be absorbed, the collision will slow and settle and end, and when the pushing stops, the mountains will have no defense left. The rain and the rivers and the ice, which even now are carrying the Himalaya to the sea a grain at a time, will simply keep working with nothing to replace what they remove. Across tens of millions of years, the highest mountains on Earth will be ground down into hills, then into low country, then into a nearly level plain, their deep roots laid bare, their summits scattered across the floors of oceans that do not yet exist. We know this will happen because we can see it having happened again and again all over the world. The worn stumps of once great ranges are everywhere. In the low, rounded hills of eastern North America, in the weathered mountains of northern Europe, ranges that in their day stood as high and sharp as the Himalaya do now, and are gentle enough today to farm. Every one of them was once somebody's roof of the world. The Himalaya are simply the tallest of the living ones, the current holder of a title that is always, in the end, passed on. And the rising and falling of ranges is only the small rhythm inside a far larger one. Zoom out further still, and the continents themselves come loose from their moorings. The great land masses are not fixed either. They wander, they collide, they merge, and they split apart, and over the deepest reaches of time they do something almost rhythmic. Every few 100 million years, the scattered continents of the Earth drift together and fuse into a single enormous supercontinent. And then, tens of millions of years later, that supercontinent rifts apart again, and the pieces disperse across the globe until the slow currents of the planet's interior gather them back once more. This has happened many times over. The one most people have heard of is the most recent, Pangaea, the single world continent that had assembled by around 300 million years ago, and whose southern half was the very Gondwana that India was born out of. Pangaea broke apart, and its fragments have been scattering ever since, which is exactly the process this whole story has been following, because India's long voyage north was one small piece of that great breakup, and the Atlantic Ocean, still slowly widening today, is one of the rifts that opened when Pangaea came undone. We are living, right now, in the dispersed phase of the cycle. The continents still spread wide and drifting, the pieces of the last supercontinent not yet gathered into the next. And the cycle is not finished. If the pattern holds, and it has held as far back as we can read the rocks, then the continents will not drift apart forever. Somewhere out ahead, perhaps 250 million years from now, they will begin to converge again and gather and weld themselves into a new supercontinent, a Pangaea of the deep future. Exactly what it will look like and where it will form, we honestly cannot say. There are competing forecasts, each built on a different guess about how the interior of the planet will move. One that closes the Atlantic back up, one that shuts the Pacific instead, one that draws everything together toward the North Pole. These are not predictions so much as sketches, drawn in fog, of a world so far ahead that nothing now alive will ever be there to check them. But whatever its shape, that future supercontinent will be built the way they always are, out of continents grinding into one another, throwing up new mountains along the seams where they meet. There will be new Himalayas, and they too will rise and hold the sky for a while and then be worn away to nothing, exactly as this one will be. Hold all of that at once if you can, and something in the mind quietly settles. We are used to treating the Himalaya as one of the fixed points of the world, the very definition of vast and permanent and eternal. And they are none of those things. They are young, they are temporary. They are one wrinkle thrown up in one collision, in one turn of a cycle that was already running long before there was anything alive to see mountains, and that will go on turning long after the last living eye has closed. Every mountain you have ever stood on, every range that ever took your breath away, is a passing arrangement of the same restless crust. Here for a while, then gone, then here again, somewhere else in some other shape. The earth has raised 10,000 roofs of the world and worn every one of them flat, and it does not remember a single one. It does not keep the mountains it makes, it only keeps making them. And there is a deep and unexpected peace waiting in that, once the mind stops resisting it, in understanding that even the highest, hardest, most permanent seeming thing you will ever lay eyes on is, on the one time scale that finally counts, a wave. It rose. It is cresting now, and it will fall in its turn back into the slow grey sea of the moving earth. That is the scale this whole long story has been quietly widening toward. The one that lies beneath the mountains and the monsoon and the frozen plateau and the seafloor at the summit, beneath the fossils and the drifting continents and the 4.5 billion year turning of the whole restless planet. It is a scale that outlasts every mountain and every ocean and every name that has ever been given to either. And it is a good scale, in the end, to lie down inside of. So let the frame stay wide and the millions of years keep running softly past, and let us bring the story and the night gently down to rest. Let the frame come back now, all the way back, from the whole turning planet to a single handful of rock. Come down out of the deep future and the wide dark, down through the thinning air, and set yourself once more where this whole long night began, at the very top of the highest mountain on earth, with your hand resting on the pale grey stone of the summit. We have come the whole long way around, and here it is again, waiting exactly where we left it. The limestone, soft and chalky and out of place, crowded with the small broken shapes of animals that lived and died on the floor of a warm, shallow sea. The floor of an ocean held up against the sky. We understand it now in a way we could not when the night began. We know the name of the sea that is gone. We know the continent that carried this stone north, and roughly how fast, and what it burned through on the way. We know the collision that lifted it here, and we know that the lifting has not stopped. The pale stone was a door at the start of the night, and the door opens now onto the whole long journey behind us, and it is time gently to come home through it. Set your hand flat on that stone a moment longer, and let the whole of it gather behind the eyes. There was a world once, warm and joined and low in the south, and a piece of it came loose, not with any purpose, only the way a crack finds its way across a pane of glass, and set off north across an open ocean, alone, carrying a cargo of living things that would never exist anywhere else. It drifted for tens of millions of years. It crossed the stretch of the world where an asteroid's long winter was killing the last of the great reptiles, and it burned as it crossed, a whole flank of it drowned under a flood of lava a million years in the pouring. It closed an ocean ahead of itself, mile by patient mile, folding the drowned sea floor upward as it came, until at last the two continents met with no water left between them and simply kept pressing, and went on pressing, and are pressing still. It raised the highest ground on the planet, and behind that, a plateau so wide it bent the winds themselves and taught a whole subcontinent to wait each year for its rains. It may have reached a cold hand up into the climate of the whole earth and helped tip it, degree by slow degree, toward the ice. And out of all of that upheaval, the new rains, the new cold, the new high country, came new animals, rehearsing for winters that had not yet arrived, and far downstream of all of it, in time, came us, looking up at the white line of the peaks, and only very lately understanding what we were looking at. And none of it is finished. That is the part the whole night keeps circling back to, because it is the part that changes how the mountains sit in the mind. The crash is not a thing that happened and ended and left these peaks behind as a monument to itself. It is going on right now, in the dark, at about the speed your fingernails are lengthening as you lie there, a few centimeters a year without a pause, as it has run without a pause since long before our kind had a word for north. In the few hours we have spent together tonight, the summit under our hand has climbed. Not by much, by less than the width of a single hair, but truly, in just the way it has risen through every hour of every night for 50 million years, whether or not there was anyone awake on it to feel the ground come up. The stone at the top of the world is a fraction higher now than it was when we set out. The sea is a fraction nearer the sky. And there is a second story folded into the first, quieter than the mountains, but just as much a part of tonight, the story of how we ever came to know any of this. For almost the whole of human time, we did not. The mountains were simply there, fixed, ageless, the very picture of the things that do not change. It took a strange and stubborn few to see otherwise. A weatherman who looked at the shapes of the continents and said, against the ridicule of nearly everyone who mattered, that they had once fit together and had since drifted apart. The patient readers who learned a lifetime later to lift a continent's entire voyage out of the faint memory locked inside a chip of cooled lava. Between them and the many who came after, they turned an eternal backdrop into a story, one with a beginning and a direction and a speed. The mountains did not change. What changed was us, learning at last to read what had been written in plain sight, in the rock, the whole time. And here is the honest shape of what we are left holding, laid out plainly now at the end, for all of it, for a story we can read in the tilt of old stone and the drift recorded in cooling lava and the crushed shells at the top of the world. Some of the largest questions inside it are still wide open, and it would be a quiet betrayal of the whole night to pretend they were not. We cannot say, even now, when India truly met Asia. The moment of contact, the birthday of the largest collision on the planet, is argued over by careful people across a span of some 30 million years, because a great deal of the crust that ought to hold the answer has gone down somewhere we cannot follow. We cannot say for certain whether these mountains cooled the world, or whether the cooling was coming anyway and the mountains merely stood up into it. We cannot even agree on when the great rains began, whether the monsoon is nearly as old as the collision or a far later gift, and these are not gaps to be embarrassed by. They are the honest edges of a very old and very large thing, being looked at by a very young and very small species that has only held the right tools for a handful of decades. The uncertainty is not the failure of the story. It may be the truest thing in it, the place where the mountain is still larger than everything we have so far managed to say about it. And there is one larger question folded inside all the smaller ones, whose shape we can feel even where we cannot fill it in. It is this: how much of the world we actually live in was set quietly turning by this one slow crash? The rains that fill the rivers, that water the fields, that feed a fair share of everyone alive, that pattern was tuned, at least in part, by a wall of rock thrown up in this collision. The particular cool, ice-punctuated world that our own kind grew up to fit. The long rhythm of glaciers coming and going that made us restless and clever and warm in our habits, may owe something to raindrops wearing at fresh mountain stone, drawing carbon quietly out of the air across 10 million years. Even the animals, even part of the shape of the living world we were born into, trace back through the high, cold cradle the plateau lifted into being. Pull hard on almost any thread of the world you know, and somewhere far back along it you come to the same knot, a continent that would not stop moving north. We will never fully separate what this collision caused from what would have arrived without it. The Earth does not run its experiment a second time. It keeps no spare planet without a Himalaya on it for us to hold up in comparison. So we are left carrying a suspicion too large to prove and too well-founded to wave away, that a great deal of what we are and where and how was decided long ago by the slow arithmetic of two continents leaning into one another ages before there was anyone here to care that they did. Step back now though, all the way back one last time, because the stone deserves to be seen against the only scale that finally fits it. The whole of this story, beginning to end, the sailing and the burning and the closing of the sea and the slow raising of the roof of the world, runs to something like 140 million years. That is an unspeakable stretch of time by the measure of a life. It is a sliver by the measure of the Earth. Set it against the planet's full age and it is only the last few % of it, the thin, bright skin on a very old fruit, and the mountains themselves, the part we climb and photograph and name, are younger even than that, a matter of only the last stretch of the sliver. The Earth was already unimaginably old and had raised and flattened whole ranges beyond any counting long before this one began to rise, and it will go on long after. The seafloor that rode all the way up into the sky is already on its slow way back down, carried off the peaks a grain at a time, down the rivers, out into the bay, laid back onto the ocean bottom it came from, to wait however long it must to be folded and lifted and worn flat once more. Up into the sky and back down to the sea and up again, the same patient rock, breathing slowly in and out of the mountains across spans of time that have no flaw to them. The planet does all of this without any malice and without any tenderness. It is not cruel to the ranges it unmakes. It does not grieve the oceans it closes. It simply does not keep them. It holds no memory of any of it at all. It only goes on making and unmaking and forgetting and making again. A vast, patient, blind rearranging of the same few pieces, turning over and over in the dark, whether or not anything anywhere is awake to see. And that, the forgetting, is what makes the last small turn of this story worth sitting with before we let it go. Because on the surface of this blind and forgetful planet, for a very short while, something has appeared that remembers. We do. We are the part of the Earth, as far as we know, the only part, that can hold a thing like this hole in the mind, that can stand on a summit and know it for a seabed, can read a lost continent's crossing off a sliver of stone, can carry 140 million years inside the soft, brief tissue of a waking mind and feel something close to tenderness for it. The planet that made us keeps no memory of anything it has ever done, and it made in us a creature that does almost nothing but remember. We do not last. Any one of us is briefer against these mountains than a single night is against the whole long collision. Here and warm and awake for a little while, and then not. But it is no small thing to be the part of the world that gets to notice the world. To be here at all, on this particular stone, in the thin sliver of time when there is anyone to look up at the peaks and wonder how the sea came to rest on top of them. That is not a smallness to grieve. It is a strange and enormous piece of luck. We are not crushed by the size of it. For one night, we are only held inside it, allowed to lie down and rest against something so old and so slow that it will carry us on without ever once knowing that we were here. So let it settle now. Let the whole of it, the ocean and the crossing, the fire and the ark, the vanished sea, the folded floor of the world, the rains and the ice and the long slow arithmetic of two continents leaning together. Let all of it come to rest in the mind, the way the sediment comes finally to rest on the floor of the bay. There is nothing here that needs you awake. The plate will go on moving north without your attention, gentle and enormous and unhurried, sliding under the sleeping cities and the dark rivers and the pale stone at the top of the world. The mountains will go on rising through the night, a hair's width at a time, and they do not need to be watched to do it. The great weight of the collision which has borne up under this whole telling is nothing that bears down on you now. It lies far beneath everything, a slow and steady pressure, holding the high country up against the sky, keeping its long, patient watch while the rest of us sleep. Come down off the summit now, in the mind. Leave the stone where it lies, high and cold and quiet, with its small crowded shells and its nearly 500 million years of waiting, exactly as it will be in the morning and the morning after, and long past the last morning any of us will ever see. Let the wind go quiet up there. Let the light go. The sea at the top of the world will keep. The collision will keep. Everything in this long story will keep patiently, without you, until one day it doesn't, and none of that is tonight's concern. Tonight there is only this, a warm dark, a still body, a mind slowly letting go of a mountain. The night has you. The mountains have their long, slow climb. Rest now